I welcome you all in this presentation related with the subject materials processing fundamentals and practical. And we are talking about the welding of metals. In this particular presentation, I will be talking about the fusion welding processes, their capabilities and the various technical aspects are related with these processes. Okay. So, we will be talking about like say the gas welding, shielded metal arc welding, submerged arc welding, metal inert gas welding, tungsten inert gas welding and plasma arc welding. Okay. So, you see the gas welding is one which can use like any fuel gas mixed with the oxygen. So, this fuel gas can be like acetylene, can be propane, can be like hydrogen, can be LPG, so or natural gas. So, there are multiple type of the fuel gases which can be mixed with the oxygen for realizing the heat through the exothermic reactions, and this heat is used for melting the fin surfaces, for fusion of the fin surfaces for developing the weld joint. Okay. But if we talk of the shielded metal arc welding, this is also known as manual metal arc welding or stick electrode welding process. Okay. This is one of the most commonly used arc welding process, and like say 70 to 80% of the weld metal is deposited by this shielded metal arc welding process, but this is primarily used for the general purpose applications, okay, which are non-critical. No? Then a submerged arc welding, this is a high heat input welding process, particularly used for welding very thick sections like the sections up to 25 can be welded in one pass without any edge preparation. So, through thickness penetration up to the 25 can be realized in one go. Metal inert gas comes in the two variants. Okay. So, in case of the metal inert gas MIG welding, this primarily uses the like argon or helium kind of the inert gases for protecting the weld pool from the atmospheric gases. So, it is really very good process for the commercial applications where we want reasonably good weld joints at low cost. Okay. So, for most of the industrial applications the MIG welding is used, but for reducing the cost, even the inert gases being costly, these are replaced with the either carbon dioxide or CO2 is mixed with the argon, or other the mixture of other gases with the argon is used for reducing the cost primarily. So, when we use the inactive gases like the CO2, then we call it as a MAG process, MAGW process instead of the inert gas. Okay. So, metal inert gas, the common name is there GMAW, which falls like gas metal arc welding. So, this fits for both inert as well as the inactive gases like CO2. Okay. So, these are like the various names through which these processes are known. Then the TIG, in the TIG welding we always use inert gases only, not CO2 is not used, because the CO2 in CO2 the CO2 will decompose, produce the oxygen that will thermally damage the tungsten electrode. So, for this is one of the reasons, and it uses the short arc length as compared to the other processes. So, use of the inert gas clubbed with the short arc length. So, this in turn helps in developing the cleanest weld metal, having the minimum amount of the oxygen and nitrogen in the weld metal and among the all arc welding processes. Okay. So, then the another variant of the TIG welding, like this you can say this is the advanced version of TIG welding, which also uses the tungsten electrode, but here the constriction of the arc is realized by forming the plasma. So, a plasma forming gas, then tungsten electrode will be used for developing the arc that will help in forming the plasma. So, plasma is constricted in this process for increasing the power density associated with this welding process, and that help in realizing the through thickness penetration of the thicker sections also using the keyhole approach. So, higher power density associated with the plasma arc welding allows the keyholing. So, this is about like the brief introduction of all these welding processes. So, starting with the gas welding process, we will be talking about the different aspects. Gas welding is considered to be the low power density welding process, and because of the low power density process, if in excess we have power density and if it is low, then the heat input, net heat input that is required for welding by the gas is very high as compared to that of the say arc here and for laser here. So, for laser net heat input requirement is very less, but for arc it is more and maximum it is for the say gas welding. So, this is one of the aspects, like the gas welding offers very low power density, and that is why we need very high heat input for realizing the melting of the fairing surfaces for development of the joint. So, the heat is generated through the exothermic reactions. About this these reactions we have already talked in previous class. So, since the flame is very flame is spread over a larger area, so they are basically the two cones. There can be three cones also, like say the two cones are primarily found inner cone and outer cone. So, these are two types of the in gas welding we find the two types of the cones, inner cone and outer cone, in case of the neutral and oxidizing flame. Okay. So, when the fuel gas and oxygen mixture, proportion of the fuel gas and oxygen mixture is almost equal, then we get the neutral flame. But if the fuel gas is ratio of the fuel gas to the oxygen is greater than 1, then we get the carburizing flame, and in that case we get the third cone also. Okay. So, three cones are primarily observed in case of the carburizing flame, but if the fuel gas to the oxygen ratio is less than 1, means the sorry greater than 1, means the oxygen is more than the fuel gas, then we get the oxidizing flame, and oxidizing flame will also have the two cones. Okay. So, that is about the kind of difference. So, that is what we can see here. In when the say acetylene to the oxygen ratio is greater than 1, we get the carburizing flame, and in carburizing flame we get the three cones, one innermost cone, then intermediate cone, and then outer cone. Outer cone experiences the minimum temperature because of the large surface area. So, despite of high heat generation, it exhibits a lower temperature, while the inner cone shows the higher peak temperature. So, during the welding, this inner cone is brought in contact with the surface of the workpiece for melting purpose, while for oxidizing and for the neutral flame we get the two cones, like one outer cone and one inner cone. So, this inner cone is particularly used for the purpose of the welding. So, the torch is placed in such a way that the inner cone comes in contact with the surface of workpiece for realizing the melting of the fairing surfaces. Okay. Since during the combustion of the fuel gas with the oxygen, it produces the like the CO2, okay, and the H2O. So, these gases are always there in the around the weld pool when the welding is carried out. So, these will be producing oxygen, hydrogen, and these will be providing the oxygen and hydrogen to the weld pool easily. So, since there is a and the protection of the weld pool due to the presence of oxygen and hydrogen around the weld pool, which is produced during the chemical reaction. So, because of this, the kind of the protection which is available with the gas welding is very poor, it is very limited. So, there is no protection as such, and therefore, the oxygen and the hydrogen, these will be these will be interacting with the molten metal and produce the compounds which will be left as oxides or hydrides, etc. So, these in turn will be promoting the inclusions. So, inclusions, since the protection is very limited, in the gas welding, and that is why we may find the oxides, nitrites and the hydrides in case of the in the weld metal. So, in order to take care of once in the weld metal, if we have very high percentage of these inclusions, then that will degrade the weld joint properties significantly, and therefore, to take care of these inclusions, what is done, protection, moderate protection is provided with the help of flux. So, the borax is one of the common flux which is used. This interacts with the impurities and helps them to remove in form of slag. Okay. Since the peak temperature which is realized during the gas welding and the low power density associated with the gas welding, because of these two aspects, you see it becomes very difficult to realize the melting of ink surfaces when using thick sections. So, if the section is very thick, so heat being supplied will be dissipated rapidly to the underlying base metal. Also, when the thermal conductivity of the metal is high, then also the heat will be very dissipated rapidly from the fraying surfaces to the underlying base metal, and that will make the melting of the fraying surfaces difficult. So, and why it is happening in the gas welding? Because peak temperature is less, it is around like 3000, 3100, and it can, like say, it can be lower also, like 2400, 500, depending upon the fuel gas which is being used. But this is significantly lesser than what we get in arc, which is like say minimum is 6000, then it can go up to 30,000 for plasma arc welding. For laser it can be further higher. The point here is the maximum temperature attained in gas welding is less, and power density associated with the gas welding is also low. So, this makes the fusion and the melting of the fraying surface is difficult, especially when the thick sections, the section thickness is very high, or thermal conductivity of the metal is high, because whatever heat will be supplied, that will be dissipated to the underlying base metal, and that will make the difficult to attain the melting temperature for melting the fraying surfaces. Okay. And so, there are two aspects, since the inclusions are more and the protection of the weld pool is very limited. Okay. Because of these two reasons, the quality of the joint which is produced by the gas welding is not really good, and that is why it is not fit for the critical applications, may be good for non-critical applications where the joint is to be produced at a very low cost. Okay. And another thing, since it takes very long to realize the melting of the fraying surfaces using the low power density, low temperature, the gas welding flame. So, so long time for melting coupled with the high heat input. So, these two things, long time for melting and high heat input, means the long solidification time. Okay. So, these things make the welding little slow, and that is why the productivity associated with the gas welding is low. Okay. And but since there is no major infrastructural set of machine and systems which is required for gas welding, therefore, this the gas welding is a low cost approach and primarily used for the casual welding applications, but not for the critical applications. Now, we will be talking about the arc welding. One of the most common arc welding process is shielded metal arc welding process. In short, it is known as SMAW. Okay. In SMAW, as we can see, there is a power source. So, mostly the power source, negative terminal of the power source is connected to the electrode, and a positive terminal is connected to the base metal. But if we are using the AC, then it does not matter, because the polarity will keep on changing. So, this will be true especially when the DC is being used. Okay. So, but in SMAW mostly we use the AC welding transformers. So, the electrodes need to be designed in such a way that they provide the stable arc, easy arc initiation due to the presence of the suitable elements in the electrode coating. So, what are the main components in this process? Like there is a welding power source, which is usually AC welding transformer, but it can be DC also. Then it is connected to the electrode. One terminal is connected to the electrode, another one is connected to the base metal. Okay. Then electrode is brought in contact with the surface of workpiece, then it is taken away. So, that means basically we use the touch method to start the arc, to initiate the welding arc. So, touching the electrode tip with the workpiece surface and then drawing it apart. So, the arc is established. Once the arc is established, heat will be generated. So, heat generated will be used for melting the fang surfaces of the base metal. So, that is how the weld pool will be created, and part of the heat will be used for, will be dissipated to the underlying base metal, and that will be producing the heat affected zone. Okay. A part of heat is also used for melting the electrode core wire, because the electrode has the two components, one is the flux and one is the another is the core wire. So, flux is all around the core wire. So, when the heat is generated by the arc, so basically the arc is striked between the core wire and the base metal, both are metallic. Once the arc is generated, then heat of the arc will be thermally decomposing the electrode coating. So, this thermal decomposition of the electrode coating will be producing the inactive gases for shielding the weld pool from the atmospheric gases. So, that is how the protection is provided. These inactive gases form a loose cover around the weld pool to protect the arc and the weld pool from the atmospheric gases. So, the key aspect related with the SMAW is basically coated electrode. Okay. So, the electrode coating is crucial, no, here. So, electrode coating must be designed properly, so that it allows easy arc initiation, stable arc, allows the desired the deposition rate, it allows the control allowing as per need to modify the composition of the weld metal, it allows the protection of the weld pool by producing these inactive gases. So, this is the coating on the electrode core wire is the most important aspect probably in the SMAW, and it has to be designed. Okay. So, the variety of the electrode coatings can be used, which will be good for like say AC welding, or which can be good for the DC welding. So, as per the recommendation of the manufacturer, suitable electrode, and as per the recommendation of the manufacturer for using suitable power supply, it can be AC or DC depending upon the kind of the elements which are present in the electrode coating. Okay. So, so there are three types of the electrodes which are commonly used. Rutile electrode is one of the most commonly used electrode. It is basically the titanium based electrode. Basic electrode is used when we want good toughness and resistance to the cracking. Okay. And the cellulosic electrode, it results in the very high content of the oxygen, nitrogen and hydrogen in the weld metal. So, it is used for the casual welding applications. Usually the SMAW uses AC welding is performed using the welding transformer. So, this is very cost effective, the welding power source, and it does not cost much actually for normal welding applications. Since the protection in the SMAW process is provided by the thermal decomposition of the flux by producing the CO2 and CO kind of the inactive gases around the weld pool, but this shroud or the cover of the inactive gases is very weak, and therefore, the protection provided by the SMAW, protection provided to the molten metal during the SMAW process is moderate. Okay. And therefore, we will have the like gases like hydrogen, oxygen and the nitrogen in the weld metal, and that can degrade the quality of the joint significantly depending upon the metal system which is being welded. Okay. Since the power density associated with the SMAW is also not very high, just like in plasma or laser. So, the heat input, because you like say if it goes in like this, gas welding, then arc welding and then laser welding, if here we have power density and the H net, then the gas, after the gas welding, in case of the SMAW, the heat input is lesser than that is needed for the gas welding, but it is still much higher than the that is needed for high power density welding processes, including the plasma arc. So, the heat that will be needed, the net heat input to be used for the welding purpose during the SMAW process is relatively high due to the low power density associated with the SMAW process. Since this process is basically manually controlled, as this is also known as, apart from SMAW, this is also known as MMAW, because this is manually controlled. So, how consistently weld metal will be deposited, how uniformly weld metal will be deposited, and how good weld bead surface is produced, how sound weld is produced, all that depends upon the control over the heat input by the control of the melting speed, okay, and manipulation of the weld pool or the proper placement of the molten metal at the place where it is desired. So, all that depend heavily on the skill of the worker. So, this requires, since the process is basically manual, so the development of the sound weld joint heavily depends on the skill of the operator, skill of the welder. So, this process needs the good skill for development of the good weld joint and sound weld joint, and due to the moderate protection, low cost and reasonably good quality weld, this process is generally used for most of general purpose applications of the welding. So, as I said, in SMAW, basically the core wire is coated with the suitable types of the fluxes. So here at both the ends the core wire is open, and in between we have the flux like this. Okay. So, this flux is composed of the multiple constituents, about that I will be talking in the next slide. When this flux is designed properly, it allows multiple aspects, like stable arc is produced. So, it will help in producing the stable arc and easy arc initiation. For easy arc initiation, low ionization potential elements like sodium and potassium are added in the flux, so that arc is initiated easily during the welding, and the good protection to the weld pool. Okay. So, the flux will be decomposing thermally, providing the cover of the inactive gases all around the weld pool. So, the weld pool protection is crucial, and for developing the quality weld. So, the electrode coating must be designed in such a way that it provides the reasonably good protection to the weld metal for producing the quality weld. Then another thing that is possible, like in the core wire, see the core wire will be corresponding to the parent metal characteristics, which is to be joined. And then if you want a special set of the properties, then those we can add certain alloying elements in the flux. So, when the flux melts, it the alloying elements also goes into the weld metal, okay, and that helps in modifying the composition of the weld metal. So, this is particularly needed when the alloying elements are not present in the core wire, but we want to add the alloying elements. So, these can be for attaining the specific set of properties, okay, like this may be for grain refinement, for improving the corrosion resistance or increasing the hardness. So, as per the need we can add suitable alloying elements with the fluxes, and when the flux melts during the welding, these elements are transferred to the weld pool, and that in turn helps in you can say adjusting the weld metal composition and attaining the desired set of the properties. Then weld pool control in odd position welding. Sometimes the coating is added with the certain constituents, okay. These constituents help in adjustment, okay, or modifying the viscosity and surface tension of the weld pool and slag, Okay. So, when the viscosity and the surface tension is adjusted in such a way that its flowability is reduced, especially when we are doing the welding in the odd position. So, for vertical, overhead, even in horizontal position, the alloying elements or the constituents are added in the flux in such a way that whatever the slag or the molten metal is produced, that is of the higher viscosity. So, in odd position, where the molten metal will have higher tendency to fall down during the welding, if we increase the surface tension, then this tendency is reduced. Sometimes for increasing the deposition rate and deposition efficiency, the metal in the powder form is added with the flux itself, like say this. So, here with the flux we can add the iron powder if during the welding of say mild steel. This is also of mild steel. Iron powder when we add, so it helps in depositing the more amount of the metal in unit time, and also it helps in increasing the efficiency of the welding process. So, they just in a nutshell, here are the different elements that can be added, the different constituents that we can add in the electrode coatings, and these are the different functions which are performed, like quartz for enhancing the current carrying capacity, rutile enhancing the slag viscosity and good arc restriking, magnetite refining the transfer of the droplets through the arc, and the CSCO3, this helps in reducing the arc voltage, producing the inactive shielding gases, formation of slag, and calcium fluoride, increasing the slag viscosity of the basic electrodes and decreasing the ionization. And likewise, there are various constituents which will be helping in either help as a bonding agent or providing the effective protection, improving the arc stability, improving the easy arc initiation, adjusting the weldment slag, the viscosity and surface tension of the slag, or enhancing the current capacity. So, the multiple elements constituents are added for the different purposes. Now, I will summarize this presentation here. In this presentation, basically I have talked about the gas welding and the technical aspects associated with the gas welding and the shielded metal arc welding, and more particularly about the different the constituents and the different roles which are performed by the flux in electrode coating during the SMAW process. Thank you for your attention.